Math 100, Lesson 10-1. It's about radical expressions and functions. All right, so first of all, let's just talk about what is a radical expression. Something that looks like this. This would be our actual radical sign. Now, what we tend to do is we call that a square root, but it's not always a square root. In this case, it is, the way that I have it sitting there. The A is considered to be the radicand, the stuff inside. All right, and so if I have B squared equals A, then I know that B is equal to the square root of A. Okay, that is a true statement, right? And that would be our principal square root there. So if I have the square root of 81, okay, I know that is 9. Because 9 times 9 is 81, so the square root of 81 is 9. Negative square root of 36, now the negative is outside, so it stays out there, and then I do the square root of 36, which is 6. We also can do this with fractions. If I have the square root of 16 divided by 25, then that would just be the square root of 16 is 4, the square root of 25 is 5. Now, if I have a problem that looks like this, the first thing I'm going to do is what's up under the radical sign. So I'm going to take care of that 36 plus 64, which is 100. And then I take the square root of 100, which is 10. Now, I'm going to do a similar problem, but it is actually quite a bit different. Okay, now this time the 36 and the 64 are not under the same radical sign. So I do each one individually. The square root of 36 is 6, the square root of 64 is 8, and then when I add them together I get 14. So quite a bit different answer than number 4. All right, if I have something that looks like a function, I said we would also work with functions. Now that's our notation where we have f of x. All right, so here's our function. Our function of x is equal to the square root of 12x minus 20. And I want us to find the function at an x value of 3. Okay, that's how I read that. Find the value of the function at the x value of 3. Okay, so I take 3 and I plug it in where there is an x in my function. And then I do what it says. Okay, 12 times 3 would give me 36. Minus that 20 would give me 16. So the value of my function at 3 is 4. The square root of 16 is 4. All right, I can think of a function as g of x. There's nothing magical about saying f of x. All right, so now I have defined for you a new function. G of x is equal to negative the square root of 9 minus 3x. And I want us to find the value of our function when x is negative 5. So we take our function, and where there is an x, we put negative 5. Now, important to have those parentheses because that's 3 times x, so that's 3 times negative 5. All right, so let's do our order of operations. Negative 3 times negative 5 is positive 15. So when I add those together, I get positive 24 under my radical. And then I want to simplify that radical. Now here's how I would simplify. I need to think of two numbers that multiply to give me 24. And I want one of those to be a perfect square. Notice this 4 is a perfect square. So the square root of 4 is 2. It comes out with that negative. And the 6 stays inside. So the value of my function at -5 is -2 on the square root of 6. That's how we read that. Now, if you need to pay attention to the directions in my math lab, if it asks you for a decimal, then obviously this would not be the answer they're looking for. If they do not ask you for a decimal, they ask you for the exact value or simplified radical, then this is what we're looking for. If they do ask me for a decimal, let's say they ask me for a decimal rounded to the nearest hundredth. All right, so here's what I need to do. In my calculator, I'll need to put -2 times the square root of 6. Now, your calculators, you're not supposed to be using a scientific, so your calculator does have a square root function, but you need to make sure you know how to use it, especially for your final exam. All right, so when I multiply those two things, I get negative, and it does say round to the nearest hundredth, so my answer would be -4.90. I prefer this simplified radical, but you do need to pay attention to the directions in my math lab. So if I have this function defined, the function of x is equal to the square root of x, if this is true, then x must be greater than or equal to 0. So the reason I say that, you cannot take the square root of a negative number. So this is the way we say that. X must be everything positive or equal to 0. All right, so you cannot take the square root of some negative number. And the next thing we're going to talk about is finding domain. Now we've talked about domain a little bit. Remember, that's the x values. Right? All right, so if we have a radical expression and we are asked to find the domain, all right, so I'm going to say of a radical expression. What we're going to do is we're going to set the stuff, now that sounds real technical, doesn't it? Under the radical greater than or equal to 0. Then solve. All right, now notice I said the stuff under the radical. These values are the domain. Okay, so let's try that. So I'm going to give you a radical expression. Actually, I'm going to give you a radical function. So our function is the square root of 9x minus 27. And my directions are, let's find the domain. All right. So we do have a radical expression. So we're going to go up here to what these directions tell me. We're going to take the stuff that's under the radical. All right. So here's our stuff under the radical. So we're going to take this 9x minus 27 and we're going to set it greater than or equal to 0. Not sure why things keep disappearing on me. All right. And then it says to solve. Okay, so I'm going to add 27. I get 9x is greater than or equal to 27. Divide both sides by 9, and I get x is greater than or equal to 3. All right, so that is my domain. Now what we're going to do is we're going to write it in interval notation. We've done that earlier in the semester. And so interval notation of x is greater than or equal to 3 would be it starts at 3 and everything greater. Remember, parentheses means not equal to, okay? And the bracket means it is equal to. So that's why I have a bracket around the 3 and then to infinity. If you needed to see a little number line sketch to decide how to do your interval notation, it would look like this. Okay, if our x value is 3 and it says greater than or equal to, it would look like this. Okay, and then to describe that in interval notation, this is what we will type in for our domain in my math lab. Let's just do some simplify problems. If I know that the square root of a squared is the absolute value of a. Okay, so there's our little rule. And so let's just practice using that. So if I have the square root of -7 squared, then that would be the absolute value of -7, which is +7. Another way to think about this problem would be, let's do order of operations and do the inside first. We would get +49, whose square root is 7. Okay, so either way that you look at that, we get +7. Okay. All right, so this time we have an expression under the radical and we're simplifying. So if I use my little rule up there that says the square root of a squared is the absolute value of a. Okay, so if we imagine this x plus 8 is our a value, then we get the absolute value of x plus 8. So notice I needed to keep those absolute values. Now number 9, we don't have absolute value around 7 because we can actually finish that. Okay, we did the absolute value of -7, which gave us +7. Let's try another. All right, the square root of 49x to the 10th. All right, the square root of 49 is 7. The square root of x to the 10th is x to the 5th. And we do need these absolute values. Now another way you could write that would be the absolute value of 7 can come out, but that x to the 5th has to stay inside the absolute value. So here's what I want you to notice on these problems. Okay, we are taking on all of these, it is understood that this is the square root. Okay, we don't usually write that too. It's just understood that that is a square root. When we get our final answer, like on this number 10, the x plus 8 has an exponent of 1. Notice that my x to the 5th on number 11 has an exponent of 5. So we took an even root and we got an odd exponent. An even root and we got an odd exponent. Anytime that happens, you're going to need absolute value. Let's keep going. When there's an addition problem like this, you cannot do the square root of each one individually. There is no such thing as that. So what I need to be doing first is factor. that stuff under the radical. Okay? So two things that multiply to be 9, same two things that add to be -6. I like faux fractions. So I end up with x minus 3 times x minus 3. Now a better way to write that is going to be x minus 3 squared. Which is great because now we're taking the square root of something squared. And so I get the absolute value of x minus 3. Okay, so let's move on to our next little rule. If b cubed is a, for example, 2 cubed is 8, then the cube root of a is b. So the cube root of 8 would be 2. Okay, so I'll write the one that I just said, the cube root of 8. Well, I know, okay, I'm going to write over off to the side just so that we can see it. I know that 2 cubed is 8. So if I use this little rule, okay, then I know I can take the cube root of 8 and I will get that number b over there. So the cube root of 8 is 2. Looking for some number, when you multiply it by itself 3 times, you get 8. But let's look at the cube root of -8. You can do the cube root of a negative number. Now earlier I said you could not do the square root of a negative, but you can do the cube root of a negative, and we get -2. Because let's think about that. When I multiply -2 by itself 3 times, that gives me +4 times -2, which does give me -8. So you can take the cube root of a negative. You cannot take the square root of a negative. Let's do the cube root of -64x cubed. So I'm looking for something that when I multiply by itself 3 times, I get 64. Well, that number is -4. X. Another way to do this would be, okay, let me just rewrite -64x cubed. Okay, I'm going to rewrite that. -64x cubed is -4x cubed. Okay, because -4 times -4 times -4 is -64. Okay, and so when I do the cube root of -4x to the cubed, I get -4x. It is okay to get a negative answer on a cube root. Now notice I do not need parentheses here. I'm sorry, I do not need absolute value here because I am taking an odd root. Okay, I'm taking an odd root and getting an odd exponent of 1. Remember, we needed absolute value if I was taking an even root and getting an odd exponent. Let me give you a couple more rules for us to look at. Because we're going to take some things bigger than just the square root. All right, so here is just a good way to write this down about what I just said about the even and odd thing. All right, so if I am taking, if n is even, all right, if n is even, then I'm going to need absolute value. If n is odd, I'm not going to need absolute value for my answer. So the fourth root of 81. All right, so let's think about it like this. You don't necessarily have to write this step down, but 3 to the fourth is 81. So notice my n value here is 4, which is an even number, right? So I take the absolute value of 3. Well, I can mathematically do that. The absolute value of 3 is 3. All right, let's just do, let me pick a letter other than N. Let me do Y. All right, so the sixth root of Y to the sixth. Notice my N is even again. So my answer is going to be the absolute value of Y. And this time the absolute value has to stay because I don't know what Y is. When it's a letter, the absolute value will stay there. The fourth root of negative 81. All right. Now, just like I said you couldn't take the square root of a negative number, you cannot take an even root of a negative number. It is not possible. All right, so here I'm taking the fourth root, which would be an even root, of a negative number. So that cannot happen. This is not a real number. Okay, you can't do that. Not a real number. Now we can take an odd root of a negative number like this. So I'm going to try to figure out what number raised to the fifth power is negative 32? Well, it's negative 2 to the fifth power is negative 32. So the fifth root of that is negative 2. Now notice I do not need absolute value because I was taking an odd root. All right, if I'm taking the fourth root of x minus 3 to the fourth. Well, I'm taking an even root, so I am going to need absolute value of x minus 3. So even root, we need those. Absolute value, odd root, we do not. So that is all for section 1. Let me know if you have any questions. You can contact me through email.